without further ado, I would like to introduce Christian. He's going to be giving a talk on do-it-yourself AI, bring your own LLM.
Thank you.
All right, everybody give it up for him.
Hey everyone. All right. Thanks everyone for being here. Super excited. How many of you guys, this is your first CactusCon? Do we have anybody? All right. Now, what about if you've been here for 3 or more CactusCons? Raise your hand. All right. I've been here for more. 4 or more? 5 or more? Gotta put my hands down. All right, so if you guys who are new, if it's your first CactusCon, pay attention to those people and ask them for all the advice and all the tricks and everything. All right, so we're gonna move pretty quick through this. There's a lot of content to cover. Just in case anyone's taking notes or trying to capture stuff, I'll put all these slides and everything on a website after on Monday. And there's a bunch of guides for how to do all this yourself, all the config files, all the commands on the site as well. So if this is something you want to try to tackle, I'm hoping some of you will want to check this out and home lab this yourself, or maybe look at deploying this in an environment. I'm going to try to leave some time at the end for kind of Q&A, but I'm happy to talk to you guys about this. I geek out about this stuff, so very happy to dive into it a little bit later. Whoops, that's not the right button. All right, so a little bit about me. I've been working in IT for, 10 years now. I got my IT job as just a student worker. I've been in cybersecurity for about 8 years. Been going to CactusCon since 2017 or 2018. Had the privilege and honor to present to this community. This is my 4th time now. Usually focus on cybersecurity talks, threat intel, and diving into specific threats or adversaries. But this time it's a little bit different. I'm one of those. This is one of those AI talks. You're going to see a lot of these this weekend. Seems to be the popular trend now. I'm hoping though that there'll be some unique things in this. If you see a lot of talks on ChatGPT or these consumer services, this presents an alternative. Although I'll kind of caveat everything with all the frameworks I talk about, all the tools, all the filters, everything can be used with those external services in case you at your company has decided to adopt Anthropic or Gemini or whatever. So I want to draw attention. There's a few important things here because this is kind of how I got into machine learning and LLMs. So I know I look like I'm attending Grand Canyon University probably still, but I actually graduated 2019. And we have a really cool thing going on there where we have a lot of interns and student workers, great opportunity for people to get into cybersecurity. And so there's a lot of junior analysts, junior contributors. I remember my first day, I had like 48 acronyms. I was asking everybody on the team, a lot of the people in here, all sorts of questions. I had a big notepad of things to go home and Google and research. And there's just so much, you guys all know that there's so much knowledge, so much breadth to what we do. We're looking at trying to secure so many different domains of IT. We kind of have to try to be a bit of an expert in everything. And so LLMs seemed kind of intriguing because of the ability to access knowledge in a very natural language, being able to maybe create something for junior analysts. I like interfacing with them, and some of our SOC leaders have gone on to be really, really good leaders, perhaps mostly because of the fact that they have to train so often. We have so many people coming through the SOC, and so that made me really interested in LLMs. Also in this role, I'm actually an IT security engineer, and my focus is, I can't really say I'm like focused on networking side or cloud side or vulnerability side because I find myself interfacing with so many different tools. And because of that, I'm reading, consuming documentation a lot. And sometimes I just need like 2 or 3% of a 500-page PDF documentation to accomplish what I'm trying to do. And so 8-9 months ago, LLMs helped me accomplish that in a very quick way, helped me deploy a command line configured networking appliance, and it was kind of an eye-opening thing of how I might be able to use these in a different way by providing the LLMs some knowledge instead of just relying on what the open source or what the generative AI community calls global knowledge, and that's the knowledge within an LLM itself. But enhancing the knowledge and bringing your own knowledge, we're going to kind of focus on that, and that's kind of the core of what we're doing. Also running LLMs locally and running them in your own infrastructure. But the second thing is the Arizona Cyber Threat Response Alliance. If you've gone to any of my talks in the past, I've spoken about this organization a lot. We do threat intelligence. We're a volunteer organization, kind of like volunteer firefighters. We like to say when there's incidents, people report stuff, we can share threat intel anonymously, but the main point is it's a volunteer. And so there's a lot of footwork involved in threat intel. There's a lot of unstructured data. Sometimes there's structured data, but there's no normalized data formats. And so this is perfect for large language models as well. There's a lot of data manipulation. Tasks like, we'll get into actually one of the programmatic projects, so I won't spoil that. Quick agenda, it'll be front heavy. We will, I'm gonna spend some time talking about LLMs, open weights, but hopefully by the end of this is all the information that you need that I've kind of learned building some of these labs and some of these environments. So if you're interested in checking it out, you're on your own and building this. I didn't submit this as a workshop. In hindsight, maybe I should have for the 2 hours benefit, but we'll go over it. And then, like I said, if you have a desire to implement any of this in your own laptop, lab, servers, environment, there's resources for that available. Now, I broke a big rule of mine. I always tell people have one main objective, one main point, one main takeaway when you're presenting. I broke that rule and decided that there's going to be several. Because as I was thinking through this, I realized that there's going to be there's a huge spectrum of people in this audience that have different objectives and what they might take away from this. So I wanted to briefly cover some of those so you can kind of think where you might fall in. Some people, really on LinkedIn, you could kind of see some people really just don't really care to invest or use, or don't see a lot of value out of using large language models, whether frontier services or local stuff themselves, but their businesses. So they're tasked with securing it, being in cybersecurity. Maybe their company's providing the service. Maybe their employees are using these services. Maybe you're in an organization and in a role where you deal with sensitive data. And so maybe you can't really use, this was kind of my kickoff point for using local models, is I can't really use these third-party services and submit all of my requests because I might accidentally put sensitive information in there. If I'm working on an open source project, maybe I can use Anthropic, but there's other stuff, there's code configuration that'd be nice to use models for, but I need that data sovereignty, which we'll talk a bit about. So hopefully when you leave, you'll see some use cases and maybe get some ideas of LLMs for human interaction and also programmatic interaction, breaking a little bit into agentic AI, although that's evolved a lot since I've submitted this talk. 2 months ago, Hugging Face released small agents. It's crazy how many projects are coming out. If anyone followed the DeepSeek release information, DeepSeek, that's a hot term too. Deep Search, I think, from OpenAI. They released, it was a pretty tremendous project, $200 a month though for the pro subscription, which is kind of the last point here, by the way. Maybe the only takeaway is you realize you don't need to pay $20 a month for 5 different services, or $200 a month for the pro license that gives you OpenAI Deep Research, because with that agentic AI surge of interest, now that we've kind of spent some time in reasoning, the community is looking at agentic AIs giving models agency, which for those of us in cybersecurity, models executing, writing their own code, we have to really pay attention to this and figure out what we're going to do with that. But from the consumption and use standpoint, there's open source projects now that replicated DeepSeek's research, Deep Research, from OpenAI, free open source, and it scores like 52% on a benchmark that OpenAI scored 62%. So you can kind of get 80% of the way there with open source. And that's kind of where open source has been for a while. It might lag behind some of the frontier models. Now that I mentioned DeepSeek, that was an interesting time because the world kind of realized that open source models can compete with the premier models. There was an interesting tidbit about these open source models, though. Another Chinese company, Alibaba, you probably heard, but Quen, their LLM research division, you might not have. there was a 2-week period where Quen released a consumer-sized model. This was a 32 billion parameter model that you could run on a desktop. That was for about 2 weeks scored the best on some benchmarks at coding in the world. This was compared to presumably trillions of parameters in ChatGPT's models and Anthropic's models, which I think shows, again, what I'm going to focus on here is choosing specific models for certain tasks, choosing models that are good at certain domains, giving models that knowledge, allowing the models to find the knowledge on its own using RAG or tools. And so that's kind of giving you a bit of a picture in the open source. And then also, this is a security conference. We need to do this securely. Bringing models on premise, that gives you some controls, and there's some obvious benefits there. But we actually got some other extensions and frameworks that we can integrate with for adding on to that. So I'm going to add some, forgive me, I'm going to take a lot of drinks too. So I'm going to add some assumptions. This will be hopefully one of my few slides where I kind of share my opinions. And I should say, all these opinions and everything, it's just my own opinions, doesn't reflect any of my organizations that I work with, although I've learned a lot from my colleagues for sure. So it's definitely a synthesis of a lot of people in this room, actually. But some assumptions, large language models present a different way of solving problems with computing. It's very flexible, dynamic, which is probably one of the reasons, and very easy to interface with. Natural language, is something that everybody is capable of. So it's as easy as sending a text or tweet to interface with these technologies, which is why it blew up and was so popular for everyone, is because immediately you can kind of at least explore if this is useful for you and what you do in your work or what you do in your personal life. So that's probably one of the harder things. Standing up your own website's gotten a lot easier, but this is literally like sending an email or text. So, but it's highly flexible, highly adaptable. It's less prescriptive than traditional coding and problem solving. So that presents itself to being a better way to solve problems than other approaches. I also, in my take, is rather than fully replacing humans' judgment and critical thinking, I think these enhance. So I don't know. I will try very hard. I do not like AI talks that make predictions about the future, or AI companies that do that. Who knows, what they're going to come out with. It is impressive and crazy to see the speed of innovation. I see announcements like LinkedIn posts of things that happened 2 weeks ago. I'm like, wow, that was 2 weeks ago. It feels like months in AI. But, who knows the future? Even if models stop progressing in their quality and their efficacy, I think there's a lot of use we can get out of them now, even the local models. 6 months ago, actually 8 months ago now, when I dove into this, that actually wasn't the case. They were kind of just trinkets. They're kind of cool toys to play around with. But I think there's been some interesting progress that we can actually start using these. So I kind of gave a few examples down here. These are force multipliers. Like I said, we've got a lot of junior analysts. Every security team, you're probably, I'd be surprised, talk to me afterwards, if you don't feel like you're on a team that's got more challenges and problems to solve than they have time to do. My to-do list is always growing faster than my to-done list. But so this is an interesting force multiplier for me. And I've been able to use a lot of local models to accomplish it rather than relying on the frontier stuff, which opens up some extensibility and some other things. So 2 words, if you go to other AI talks, I want you to kind of keep these 2 words in mind as well. There's kind of 2 ways, I think, 2 categories of solving problems with computer programming. There's this traditional way that's deterministic, where we prescribe what we want to happen. It's if this, then that. It's predictable. You have control. If there's bad output, it's kind of the developer's fault. A lot of us, a lot of people who contribute to open source stuff love to put blame this author for this if this doesn't work and all that. So it's very good though, because the developer can take time to fully understand the problem and create a good solution for it. Requires the disadvantages. It requires extensive pre-planning, explicit logic. You might not think of every scenario. So handling things like natural language becomes very complex. And then there's the probabilistic approach. Everyone's familiar enough with generative AI services to kind of get what this is meaning now. It's a different way of solving problems. It's going to really give a good estimated guess based off of a lot of trained relationships and weights and impressive. I still find that probability and statistics, that it's consistent enough and representative enough that it's able to be useful in these capacities, is really fascinating to me. But This is just very, it's flexible, can handle natural language, can handle maybe novel problems that haven't been solved yet. And you can really play with the numbers too to make it more creative. This is actually a scale, so I wanted to mention that. One pro tip is if you ever use LLM services, local or remote, for programming or data science or anything that's more cold. I like to think of it if it's cold, hard data. Turn the temperature down. All these services have a temperature gauge, and that's kind of a slide between deterministic in the sense of how consistent and how probable and how likely the output is based off of the preceding tokens versus the creative. If you ever see the or creative slide, if you see that, programming is not very creative. Don't turn that. A lot of times defaults on 8, and that alone, I see a lot of. I've suffered, in 3.5. I'm like, how are people using ChatGPT 3.5 for coding? And frankly, it wasn't that good at coding. I think it's 180 billion, 85 billion parameters, 175 billion parameters. It's amazing. Now we have coding models at 7 billion that can outperform it. But a large part of that problem is the model's too creative. So this is 2 categories of solving problems, but I also want to note that there's a probabilistic kind of slider involved in this, and that's the temperature property, and that's the one thing that you might want to change most, because if you're programming or dealing with structured data, if you're outputting structured data, choose a low coldness. All right, so large language models. I'm assuming everyone's heard of ChatGPT and Gemini, but I wanted to break this out into something. So obviously, there's a lot of providers. You recognize all these logos. Maybe you might not recognize. Oh, that's interesting. Didn't know Google Slides did that. This is Gemini's model, so Google's model. But each of these have stakes. Believe it or not, Microsoft isn't just consuming ChatGPT. They do have an LLM research division, and some of my coworkers will laugh at me, but I hate to say it, but they did a really good job with their last model. So props to Microsoft and their open source LLM division, their Pi model. But large language models, it's just text prediction. Obviously, I'll kind of note that, a lot of image prediction, audio, there's a lot that kind of falls into this. Those are other generative models, but we're gonna be looking a lot at LLMs today. So there's instruction tuned models that I wanted to call out pretty early on. When you look at the open weight models and you're dealing with open weight models, you'll see different model selections. In ChatGPT or Google, you might have like chat completion / I don't know what the phrases are anymore. Autocomplete versus, chats. But what those models are called are instruct versus base models. So those are 2 forms of models that most of these models will actually be available in. So the base model is kind of what we first had, where it's just an autocomplete. So if you hear people say like it's like a bad autocomplete or it's a good autocomplete or whatever, it actually is one of the first, one of the easiest things was just to do autocompletion. So if you have, so this is, by the way, as you guys see this demonstration, this is a local coding model, 7 billion parameter Quen model. And you can kind of see that as I type stuff out, and I purposely made a mistake here, we'll get to, I really hope you guys can see that. But if you can't, it's auto-completing stuff. So I'll write some stuff, I'll tab autocomplete. If you've used Jedi or other autocomplete tools, it's a lot like that. In fact, some of those used a bit of machine learning or a bit of probability, I should say, for autocompletion. Obviously, this is fully relying on large language models. But the coding models, are really good at this autocomplete. They can gather the syntax around it. And this is kind of what we first had. These are base models. So if I draw attention to this because if you use a base model and you try to start chatting with it, you're probably gonna have a really bad experience. Like, what the heck's going on? You want to choose the model based off of your use case. These are two distinctions. There's also reasoning models. There's image capable models. There'll be a lot more that we'll look through, but so this is auto completing as I'm typing. I can kind of what I have configured for this is if I've typed a character, I delay 250 milliseconds, it'll perform a task of sending some of the text to the model to perform some inference and try to get me some content back. And it does a really good job. And from my experience, some of these small models, when you start doing larger things like having it write a whole script or change all of your data, you often want larger models. And this is where a lot of people, really benefit from the monolithic, huge models, the trillions of parameter models that the frontier models produce. But this is an instruct model. It's probably what you've interfaced with mostly. Again, they solve different tasks. You could see in this case, again, within my environment, this is, like Copilot. I mean, I should have mentioned that. Obviously, this is what we're kind of looking at. I'll note that this is completely open source. We're going to introduce you to the extension that I'm using, but I'm able to use a different model, and I'm asking it here to, improve logging, error handling, document the script, the type of stuff, error handling, logging, applying security, best practices, the type of stuff that you might kind of not think about or not do. I at least had terrible code comments and very poor error handling. I'm not a developer by trade or anything, and I have less experience with that. And so it's really nice to be able to just produce what I want and then have the model perform those tasks for me. So in this case, I literally have it create a whole new script for me, copy, paste, dump. That's an instruct model. It's following commands. They're trained on they're trained on a lot of data, but one is an emphasis on following instructions. And since we've been going down that path of instruct models, these have gotten a lot more useful, but this is where I'll kind of start drawing some lessons or, things to keep in mind. It is very, it follows your instructions, and it's very poor at assumptions. So, it writes, often we'll talk a little bit about LLMs writing bad code, but they will perform the tasks that you tell them to and very little else. There's actually I forget what the term's called, but there's a bit of a kind of punishment metric for length. So a lot of these models, try to be a bit more concise. So they will exclude things like error handling, logging, good best practices, security, control, security, best practices if you don't include those in your request. So the first, tool, open source tool that I'll present to you guys is Continue. If you pay for Cody or if you pay for, what's some of the other ones? I used to pay for a few of these. I have to go back farther than I thought. Copilot, Cursor, Cody. This is what that's doing. It's OpenAI API compatible. So that's an API standard. And so if you want to run a model locally, have it help you code, this is a great extension for connecting to that. It's got Ollama extensions if you've checked out that, but most of the frameworks this will be able to integrate with really well. So you can save yourself $20 a month. All right, so now we're kind of getting into why do large language models locally anyways. And so there's quite a bit of content here, but just pretty quickly, you have a bit of different options. You could just go directly to an API with one of the frontier services, OpenAI, Mistral, Anthropic, the ones we all know. That's how people consume this stuff, mostly. Web interfaces, maybe API usage. There's cloud SaaS. So, you can choose to use your own language models that are open weights that are available in the community, but maybe host those in your Azure cloud environments or AWS environments, or use Hugging Face and their local models for inference. And that's cloud hosted SaaS. So you can maybe spin up your own system with H100 GPUs and run that in the cloud. Although, everyone wants GPU cycles right now, so it's quite expensive. And then going back to the cloud SaaS, Hugging Face, AWS Bedrock or SageMaker, Azure, GCP has an API for some of their stuff too. So you can consume these things as services and run different models there as well. And then there's this final category, self-hosted local models. The interesting thing is, since these run best with GPUs, there's a lot of just consumer gaming GPUs that run these models very, very well, especially for smaller models. You can get really fast, you can get faster experiences than most of the frontier models if speed's, of interest. But most of us, I'm mostly interested in quality. And so we'll spend some time focusing on how we can improve that. But self-hosted, obviously you got a whole spectrum. You could spend $30,000 on an enterprise, large language model server or machine learning or generative AI, whatever, CUDA server with tons of GPUs, or go the AMD route. You can choose an old gaming desktop, which is what our lab's hosted in right now, do some sort of combo to spread things out, because you will it's not just one model. You'll be having lots of different models for different use cases. So you can obviously get flexible with this, but this gives you some flexibility. And I think importantly for many of us, it gives us some data sovereignty. We can control what data leaves our network. We can perform inference without having to worry about not just, big cloud customer, big generative AI provider being compromised and all their data leaks, but just, consumer accounts being compromised. We could put our controls around accessing these things, make it only accessible through zero trust network access, which is how my home lab's accessed right now, or you can make it accessible through your VPN or whatever. You can apply our traditional security controls rather than just hoping no one logs into the OpenAI accounts that people might be using. So it just gives us a lot more control over that. So I'm going to talk a bit about models here. Focusing on quality first, I wanted to give a bit of context, I guess, about these billions of parameters, in case that's kind of a new term. Parameters are the number of attributes and properties that are given numerical values, and there's billions or trillions of these, and that's what make up the weights. When you hear people mention that phrase, these weights that represent the statistic and probabilistic relationship between the tokens in these models. And so ChatGPT-2, which is actually open source, it's the last open source model that OpenAI open sourced, and it's 1.5 billion parameters. ChatGPT-3 is 1.75 billion parameters. I think the cool thing here is size of these models isn't actually everything, because we have 3 billion parameter models from Meta that can outperform ChatGPT-3 on some benchmarks. And I say some, I'll say some with everything, because there's some small models like math models that outperform monolithic huge models. So there's tons of different metrics for measuring these. But so, now we're at 1.8 trillion, and that was, Hotz kind of leaked that in a speech one time. Most of these companies don't say how many trillions or billions of parameters their models are. But I wanted to give you some ideas. Some small models, these are all considered small. Llama set 3.370B is really, this is actually, if anyone's heard of Llama, it got popular at 3.2 from Facebook. They had a 405 billion parameter model, 3.2, very, very capable model, frontier model for its time, from Meta Facebook. And now they have a 70 billion parameter model that outperforms it. So the cool thing for us being, GPU poor is the saying in the AI community, compared to these huge AI companies, is these models are getting smaller. And you can see on this right side, the open source models are accelerating faster for some reason. Tons of speculation, but for some reason they're accelerating their capabilities faster. They're catching up to some of the big players faster over 2024 and now even into 2025. Obviously DeepSeek is open source, so that kind of was an outlier. But there's even, like I said, consumer models that can outperform or at least compete with some of the quality of these larger models. So I have a few models. These are some models I really like. The cool thing is most of these companies are always releasing models, and usually the latest model is kind of often the best model, just because we're still learning how to do this stuff well. Where I think who knows if we're at the peak or if we're just learning, the fundamentals, and we'll do much better. But in whatever case, these models have been much more capable at smaller sizes. And when I say capable, I'm referring to quality, which is the consistency, reliability, and the overall quality. When I say quality index too, in case you guys see this and do your own, research and checking out, quality index is a common term. It just kind of averages tons of different benchmarks, and these benchmarks are created by specialists in their fields, or they're one of the popular ones by Aider actually uses like a code academy, and it uses 130 questions from that code academy and has the models try to perform these and sees if it gets it right. So there's a whole bunch of different ways that this quality is it's supposed to represent an average quality of the output. So coding score, I like this, LLMs, it's text manipulation. So coding seems ripe for kind of disruption, right, with these models, because that's all it is just text. So I'm mainly talking about speed here, but I did want to point out that I've highlighted Quen models. I don't know why I have Ollama there. Anyways, there's 3 models here. And you can see that these seem to be pulling above their weight class. Again, this is percent completed correctly. So out of 130 questions, 8 are benchmarks. If you look it up, how many of these were completed correctly by the model itself. So, Gemini Claude O1, there's no benchmark for it yet, but O3 for sure would be up on top. Supposedly, I haven't been able to find any peer-reviewed article. Try to rely on that, by the way. People on Twitter say all sorts of stuff, but there are a lot of scholarly articles about this, about benchmarks, and you can see the data sets. And so look into that if you dig into this yourself. But supposedly, there's one benchmark. Actually, it's a competitive coding platform. And O3 was just benchmarked. Today's Friday, so Wednesday. I haven't seen the results or data, but supposedly it scored, supposedly there are 7 American programmers in America who can score higher, or who have a higher score than the O3 model. So now I'll talk a lot about that at the end, but that's just kind of giving you an idea. So that was a huge leap forward in coding. Reasoning really did correct a lot of the weaknesses of LLMs, especially when it came to coding. But I love this as an open source kind of enthusiast. There's a lot of big, heavy players. These are 4.0 trillions of parameter models. When Quen 2.5 came out, I mentioned this earlier, like I said, for about 2 weeks, it was on a lot of benchmarks, the best coding LLM in the world. Again, run it on a gaming desktop. I'm surprised that DeepSeek made the news when that didn't, because for a lot of us in OpenAI, or, open LLMs, can't say OpenAI because that's the company, but open source, open weight LLM community, that was really crazy to see a 32 billion parameter model compete with trillions of parameters. And I still think this is probably one of the better coding models today, although Claude released a model 2 weeks later, and it went from like 74 to 77%. Actually, you could see it's probably at, 77. But so there's also quantization. If larger models obviously are slower, require more resources. Quantization is a way of reducing the length of the values. So if you think about floating points or decimal points, a lot of these things have like floating point 32. So 32 values, very precise, 32 numbers after the decimal point. And quantization, I don't know, I hope I'm saying that right, is a way of reducing the precision, because when you think about all the math and all the averages that come into play for the output of the model, we can quantize these models to maybe 4 decimal points, reduce the model size by a tremendous amount, and lose only a little bit of precision, sometimes like 10-15% precision to go down to Q4. So I'll kind of mention this. Now, if you're doing coding, you probably want higher precisions. I like Q5. If you use Ollama, which is super popular, and I'll talk about Ollama, it's the default's Q4. So just kind of note, you might want to just grab a higher quantization model. F8 is a really good one, a really good balance too. So I always get asked this question, so I created this slide. And again, I joke because I like to rag on Microsoft, and I'm a Linux user because I got annoyed with Microsoft primarily at first, and I thought I'd have a buggier time on Linux, and didn't find that to be the case. But I got to hand it to them. Their Pi 4 model was pretty impressive at 14 billion parameters. This is something that you can theoretically run on it's 9 gigabytes of RAM at Q4, Quant 4. So this is something that you can run on some gaming laptops or some laptops with GPUs. And you can see here that's only 2 categories that it outperforms a lot of these things. But ChatGPT 4.0, that for close to a year, that was the frontier model. And you could see that in terms of, and I forget how to pronounce these, but this is some like graduate level questions in their domains test, and then obviously a math test. It outperformed GPT, but the most parameters, it can compete with some of these larger 70 billion, 72 billion struct models. So I really find this just to be a really reliable all-around contender. Could do some coding. So if people, if you're wondering what model to check out, I think this is actually a really capable model that can run on most hardware. And if you are, brave, or if you at least really want the best bang for your performance, then you got to look at the Chinese models right now. Just benchmark wise and experience wise, they're doing really well with open source. Most of the companies are open sourcing all their models. So whatever they frontier, whatever their best thing is, they'll open source the weights. And what I mean by that is most companies aren't providing their source data that they trained it on in the source code, which is what open source truly means. So you'll hear open weight models. There are a few truly open source models, but most of these aren't that. So, Quen family model from Alibaba is just benchmarks. If you're wondering what's doing the best for, small models, the Quen family is just doing the best right now. I love to see Google Gemma. They just grabbed someone from Hugging Face company. So I love to see some Gemma Model 3 come out and models from Facebook to disrupt this. But right now, that's what's going on. DeepSeek, obviously the R1 model, no one can really run it though. So it's cool that they released a huge monolithic model, but you're probably not going to be running R1, true R1. And I do want to call that out, because if you see people like running DeepSeek on their laptop and they're like, this is garbage, it really is, because it's what's going on is it's running a distilled model. So they're using that reinforcement learning, but on other models like Llama or Quen's family of models. So 7 or 8 billion parameters, 7 billion's the Quen and 8 billion's Llama. And those models are just too small for really constructive reasoning. So they're not that useful. So we were talking just earlier, Josh, about, the reasoning models are really cool. They do perform better. I don't get a lot of use out of them, so I can't speak to them too much, but there's the tests. I'm sorry. I remembered I wasn't going to I knew I wasn't going to remember these names. So scientific reasoning, you can kind of get an idea. Most of these, you'll see this image a lot when you're looking at models. And so their scores and these tests are really common. So you can kind of see what we're assessing in each of these. So it's good to kind of know what those terms mean. But also interesting, like simple QA, like the score is a 3, but versus a 39. So, know what your model is, what you're wanting to accomplish. The trillions of parameter models can be generally better at all things, but what we've definitely found out now is dedicated models like coding models can really, hold their own with these trillions of parameter models, and they're much faster, obviously, even running on, old gaming desktops. All right, so it's supposed to play automatically. But, in terms of speed, this is going to depend on what model. If you're loading in memory, we'll talk about hardware requirements. But you can kind of see this little demo that I said hello because I wanted to note to you guys all, and just in case you experience this and you're wondering, it does take a bit of time to load a model into memory. It's a large amount of data, depends on your disk speed. So the first response was really slow, and then I asked it again, and now I'm getting 169 tokens per second, which is faster than most of the fast mini model services that you'll get, because Llama 3.2 is just so small and so fast. So, and it's actually really decently capable. It's the only model sub 7 billion parameters that seems to be universally kind of at least respected with a certain level of, it's not going to do well at coding, but it's actually pretty decent at RAG and handling data and being precise with that. All right. Oh. Yep. No. Okay. So now you get building the team. So I mentioned earlier that when we're looking at running these local models, there's a few things. When you have a smaller model, you've got less global knowledge. But I think that's okay, because we've kind of all experienced that maybe even the larger models, like we don't want to just rely on random stuff on the internet, especially when you're doing, enterprise type work, or if you're obviously creating like a customer interfacing application, then you're dealing with data like that's for your own company. Like I've not had great experiences with most of these kind of chat services using LLMs, but I had to say, even though it was a year ago, I actually found some use out of H&R blocks, and it was actually able to like help me accomplish some things pretty naturally and easy for me, because I need things explained like I'm a 5-year-old. So that's a pretty common prompt for me. But so when it comes to this, I want you to kind of start thinking, if you have an idea of your application, cool. If you don't, maybe you can just play along, imagine what might fit into your org. But there's this concept in LLMs that is like this world of text. And so if we have all of our data knowledge in a world of text, we've got databases that we can either, maybe we need to do querying or formatting, or need drivers to create the data into text. But I'm thinking about like Windows, system logs. We can at least present all this data or record data and capture data in text. And so logs, manuals, guides, tickets, SIMs, outputs, inputs, reports, guides is kind of a big one for me. Like I said, manuals, I hate like when I first don't know a project, and I'll usually procrastinate, and I'm like there deploying something, and I'm like, I don't want to stay long. I need to accomplish something really fast. The models can be quite useful for allowing you to find at least the part of the documentation. It can cite obviously the original documentation. So when you're bringing your own data to these models, you can use much smaller models because you're not relying on the model to know or to get things right. You're just relying on the model to help you manipulate and traverse the data and the text that's in it. I keep a lot of notes. For years I've used, we were talking about Atom code editor for years. I don't know why I adopted Markdown as my note-taking, which is kind of just a way of marking kind of plain text notes. But so it was great because I was excited, a year ago, I was excited about the day where maybe I can have a local model on my laptop and I can have it reference all my notes and have kind of this internal private knowledge database. And I can just access that locally. And I thought that was years off. And then during the summer, I was starting to be able to play around with that, which was really pretty exciting. But another thing too, well, a lot of you guys in the room, might be able to relate to this with me. Like sometimes we're trying to automate stuff, then the data's either unstructured or there's lots of different data structures and formats. And so, one of the roles I have is SIEM. And so it's nice because, when you're putting stuff into the SIEM, well, modern SIEMs, a lot of them, you don't need to worry about this data structure and you just trust the, these SIEMs to do schema on demand, stuff like that. But when you're taking stuff out, when you're trying to use programmatically, you don't have that benefit. So LLMs also allow us, because they're dynamic, dynamicness, you can work on unstructured data, which was a big deal for me in threat intelligence, like I mentioned earlier. So that's kind of like the foundation. So now we're going to look at, I don't know what term to call this, which is bad because I know I'm the presenter, but there's so many different terms that people have, and there's so much debate or no true definitions about like what's agentic anymore, what's model, what's persona. The framework that I operate within is a community called Open Web UI. And so they call these models, which is weird because we call like Llama a model. So I don't know what to call these. I like to think of them as personas. There is some agency to these because these, I've given these kind of different personas I'm going to go with. The ability to call tools when they feel like they need to. And that was kind of what agentic meant 5 months ago. Now, as of 2 months ago, there was a new framework where the models during inference can call tools and use the data during inference. So that's really, I think, what agency means today for these models. That's at least what the industry's adopted. But these consist, for us today, we're giving them some knowledge. We're giving them a well-structured system prompt, because I want to go back to something I said earlier. These models, the weights relationship between what you put in and what is outputted are just that. There's a weight and probability relationship between the input and output. So if you don't specify things, these models might make assumptions, or they might just bypass certain things that you might be interested in. That's why, if you guys remember, there was so much a craze about prompts and prompt sharing and prompt engineering. What was the term? And there may be some prompt engineers in here, so I appreciate you guys. And that is still, you can get impressive results, or it's interesting how much better the results can be with good prompts. But now we've, obviously expanded a bit beyond that by giving them data during inference with RAG, system prompts to give clear objectives, parameters, things like if you perform RAG and you don't get any data back, then tell the user, don't just guess. I don't like the term hallucination because it kind of personifies these things, but that's what we've adopted. I don't like a lot of the terms that what we've chosen in this community, like jailbreaking. Anyone think that's a weird term for LLMs? It's where you kind of trick the LLM to get past some guardrails. And really, if anything, it uses a lot of the same tactics as social engineering. It's a little bit closer to that. Jailbreaking like an iPhone or rooting your Android device, it's like operating at a level that doesn't have those restrictions. Anyways, it's just kind of a funny thing. They've adopted a lot of our terms in security, and I don't like it. But and then of course we're choosing a model based off of what task and what domain, and then giving them tools to work with as well. So Yeah, I'll keep things rolling here. So we got Sony the SOC Analyst. This is my first one, and actually the hardest one really to work with. Analysis is kind of a hard thing. Maybe I should check out some of the thinking models a bit more for this. But what I did find is it was really useful at explaining things to me that are a bit harder for people to read. Like anyone, some of us in the room might be familiar with, maybe have written some Suricata rules or Zeek scripts. Sometimes it's nice to know the logic that went into surfacing an alert, so it's not just a black box thing, so we can understand specifically what an alert's presenting to us. And so that's one of the nice things I have found that these to be useful for. But I'm starting with the hardest one, which is, SOC analysis to represent that. There's just so much criteria, so much, tribal knowledge in an organization that goes into SOC analysis. And now some of you guys are at MSSPs where that doesn't exist, and then that makes it a lot harder. But in any case, this is Sony the SOC Analyst. I've given them some standard operating procedures to help guide. The idea here might be like a junior analyst is interfacing instead of asking people on other teams for guidance and step-by-step things. If you already have standard operating procedures, why not complement those standard operating procedures by dynamically combining the SOP with the alert and with some of the maybe additional data, and so that the analyst is still walking through it, doing all the critical thinking, but there's a bit more guidance in that. And so in this case, we had one conversation. We started out with talking actually with Logan the log analyst. So in this case, I switched the sides. Thank you. But Logan the log analyst, which has a different, doesn't have RAG and has a different model that's better for log analysis, gave me some explanation of the logs and what happened so I can help me interpret it. And then Sony the SOC analyst went and helped me understand from a cybersecurity perspective what information was important and how to interpret it. So to do the next persona that we have is a compliance analyst, which was a bit easier just because we're often referring a certain set or standard of policy or guidance. And so, asking the models some of these questions, and actually have an example on my website of this exact question. The models can get the answers wrong. They can get, if you ask about like reportable breach requirements and stuff like that, it might kind of misallocate some other report or some other more common policy and apply that to the question that you're asking, even though it's about a different policy. So in this case, we can use RAG, which is using a probabilistic way. And here's some models in case you check this out yourself. Using a probabilistic way, which is kind of just a dumb and easy way. It's not always the best way. If you can write a query and get the exact data that you want to your model, that's going to be the best. And it's a deterministic way of making sure the model has the data that you need. But RAG is really popular because as long as you can translate it into text, you can tokenize this, put it in a model, and really quickly and really reliably get data back to your model so that it's operating on actual facts and knowledge that you trust instead of just relying on random stuff on the internet that the company happened to train off of, right? So you can kind of see an example. There's docs, PDFs. This is a demo environments directories for some RAGs, text, PDF, whatever. As long as you can translate it to RAG, you can do that. So another example of that, like I said, I have all my stuff in Markdown. I've adopted Obsidian. There's a plugin called Smart Second Brain that helps you vectorize. If you've used that term, that's just where we're turning numerical data or really whatever. But in our case, we're turning text data into numerical data, vectorizing these, and much like the token values that the models are using, and allowing the models to use probabilistic likelihood of the document being relative to your query. So in this case, you can kind of see on the left here, it's a graphical visualization of all of the different documents I have on different threat adversaries. I've got some GitHub projects, and you guys, some of you have seen me present on tracking these adversaries before and using threat intelligence, and Obsidian had this graph view that's supposed to help you navigate your knowledge. It's really cool to kind of like look at your knowledge, but it's actually kind of hard to navigate. And so sometimes I want to ask questions of this data, and it might be 10 documents, it might be 2 documents, it might be 3. And so the RAG allows me to just use probability to basically dump the output of those documents in the LLM while I'm asking it a question about a particular topic. So I ask it about Cozy Bear, APT20, recent information, and it was able to find some documents and give me a concise summary of that. I have another demo of that, a bit more in depth while I talk about also the privacy. So some of the benefits of doing this, this is all on my local system. So I don't really want to send necessarily all of the intel. In fact, some of my stuff is from like incidents, maybe within the actor community or other things. I'm not going to send this off to other third parties. I don't really want this to be stored anywhere where there's other logins, just because I'm silly like that, or maybe you're in an organization or in a role where that's also important to you. So I can talk to my documents completely locally. Actually, I can run it on this old laptop. It's got a 4 gigabyte VRAM GPU. I can interact with my own knowledge management. I can use unstructured data. I like the idea of this natural language querying information. Our SIMs where we have just static language. Actually, there's Pete Kim's and I talked about this from Raytheon. He's anyways, the natural language querying, is a pretty interesting potential maybe where we can talk and ask information of our data in a more natural way without having to rely on more advanced skills for querying. And I think about that a lot as, a team with a lot of junior SOC analysts. Splunk's easy and simple enough to learn, but the dream is maybe just being able to ask questions of your data and be able to find it for yourself. All right, one thing I'll note is there's limited precision. This is based off of probability, not necessarily heuristic meaning. So that we're still kind of exploring different ways of data retrieval, but this is probability, the relationship and likelihood that something's going to be relevant based off of your question. All right, so now we go into the tools, which I think is the more important part. This is where agency starts getting there. So there's a few different places we can implement tools. I'm going to go through this a little fast, but like I said, all this stuff's online if you want to go into it later. But we can basically perform operations before the data hits the model for inference, during inference which is the new definition of agency, or after inference. So you can enrich, filter, do all these sorts of different things. There's a few different types of tools, but you can kind of get the idea. Maybe you're calling an API. I love one day for these LLMs to write SPL. I've tried to poke around a little bit with that, but unless it's like SQL or something like that, it's just not really good with the syntax yet. Maybe if anyone's in this room is really good with explored fine-tuning, that's poses promise for being able to help with syntax reliability for these model outputs. But I want to call out one specifically. I mentioned that everything here can be used on external API services as well. So one of the things I was interested in is this data loss prevention, not just if I'm using external models, but hey, layers in defense. Maybe you're running open source models from DeepSeek and you have some stuff containerized and isolated, but you also just want to, why give the data to the model third party or local if you don't need to? And so there's filters, there's dehydration, rehydration of data concepts that I have actually built, and I've got open source GitHub projects that are compatible with the OpenAI community, but they're just they're theoretically compatible with any OpenAI pipeline that you might adopt. We're going to rush through this a little bit. So I want to give you guys the framework. So I've chosen OpenAI. It kind of hosts an OpenAI API, which is an API standard, and obviously acts as a web interface, and also it's a progressive web app, so you can install it on a mobile device, and it acts like a mobile app. But the API is important because I think that when we're talking about RAG, it's very similar to this concept of just contextualizing the LLM inference with whatever environment you're operating in. So I have a command line open source project that I built, Chat CLI, because some systems maybe you just don't have a GUI interface. But this is just a Python framework for referencing an OpenAI. OpenAI API, so I can ask questions in text and train, give some context to my chat session, maybe about SSH. In a later example, I'll show that. Or I obviously mentioned integrating with an IDE environment. There's great alternatives though, and I have to admit, OpenWebUI is not the most popular, probably not the easiest either. All my resources, I try to make it easy on my website. If anyone wants to dig into that, I use OpenWebUI because it's got user management and OCID integration and group and access control lists and all these great things that make it good for a team. But if you just want to run this stuff and check it out, I haven't checked it out myself, so I don't like presenting about stuff I don't check out myself, but the community seems to be determined that anything LLM is a very easy way to get engaged with this. It helps you download and manage your LLMs. It's all GUI based, Windows, Mac, and Linux. So it's a great way to check it out. I also liked LibreChat for the longest time, like LibreOffice and other things, kind of like an open source chat thing. All of these can interface with, by the way, OpenWebUI, most of these things you can kind of connect with Google's API services, Mistral, Azure AI, ChatGPT, Anthropic. So it's also nice. You can kind of just have several columns of multiple chats, even if they're frontier services, and kind of compare the outputs. And that's how I've been able to get a sense of these models comparison over a while. I don't really know how to say this. I think it's the most popular, in terms of stars on GitHub, but Booga is a very popular interface for giving like a GUI user, interface for these things. Talked about OpenAI. I wanted something on my phone because I used to spend $60 a month on Google, AI, what services, ChatGPT, and then Anthropic. So I had pro licenses with all that. I'm glad to say I think I spent $11 on subscriptions in like 3 or 4 months with Anthropic using these local models. So it's saving money. But I really liked having conversations with AI when I was like doing yard work or something like that. So having this on mobile, being able to make calls. By the way, I shouldn't, in case I don't get time, on my site and a part of this framework, there's local models that I use for speech to text, text to speech. You can have these models speak to you in really decent quality, and even open source projects for web search, which we were also speaking about. Let's keep things going. So this is the stack. Like I said, you feel free to take pictures if you want. I'll put this all up on the site. But this is like the stack that I happen to use to accomplish all this. Speech to text, text to speech, RAG, all these. I even threw in there like some of the security controls. It really allows you, like, in fact, feature wise, it has some features before some of the major models. So like you can talk to the models through a desktop application, which I don't know, maybe the pro version is different, but for a while you couldn't do that on ChatGPT. Anthropic came up with this artifacts feature where you can have the LLM write code and build a web app and then render that in your site, in your chat, which OpenAI WebUI had like days after they came out with it. Deep research, plugins, extensions, all these things make these open source options really, really powerful. So, I mentioned Ollama. I would say production wise, you're probably not going to end up using Ollama, but if you're not using anything LLM, Ollama just makes it super easy to run, manage these models. If you know Docker, like, how there's like 9 commands that you use for Docker mostly. It's kind of the same with Ollama. So you can Ollama pull, Ollama run. It's super, super simple to get engaged with. And it has it's very popular option. So the API, while it's not an OpenAI API standard by default, they do have an OpenAI API compatible endpoint. What that means in simple terms is just it can integrate with most of the popular tools out there. I'll go past this really fast because we kind of saw this bit, the base models, but you can get the idea. It integrates with your IDE environment. You don't have to pay for the Copilot services, or maybe you're, don't like the idea that open source licensing is being violated and don't like the ChatGPT or the Copilot model or whatever your reasoning. Maybe you've got developers who maybe have secrets in their code and you don't like the idea of that being stored in an account somewhere. These models, when they perform inference over an API, the benefit is you can control everything. So you could say, hey, this is my greatest example, a great example for securing stuff. You run these in containers, use podman, don't run them as root, don't give them privileged access, prevent them from being able to make outbound network connections, isolate it, treat it like kind of like a sandbox, really, because all it's ever going to need to do is receive something and then send it back. But then also when you're performing inference over an API with some of these frameworks, everything's in memory. You might want to enable some sort of logging in the future, but if you don't want to, there's a benefit there for some of my use cases, at least. I talked about this. I'm running out of time, so I'm just going to keep moving forward. This is a good example of Stacy, who can write scripts for us, and she's given some instructions on writing code securely and adding comments and logs and stuff that I never like to think through. But also you can see here the artifact thing. So she was able to write all those visualizations I had of those charts. By the way, those were all generated web apps from these local models, not even the frontier models, because running the web app, I mean, like, how many of you would go around saying, like, I'm an HTML programmer, right? Like, no one wants to write HTML, so it's great. You might want to write the other code and have a responsibility in other realms of software engineering. The stuff that we just need just done, it's really nice to have these models perform for us. So I will, for sake of time, go through some of this a little quickly. But, you know, when it comes to coding, like I said, the model's not going to assume much that you probably want it to. So just give it instructions, give it good prompts, understand the code that you're running still applies. Think of this as stuff from Stack Overflow, because a lot of it is. There's bad code on GitHub. I'm sorry to say I'm a contributor to that. I started writing stuff on GitHub in 2018, and I can guarantee that a lot of stuff had vulnerabilities and dumb things because I didn't start with a good foundation of programming and writing code. And so some of my code contributed to the vulnerabilities that ChatGPT creates now. So run code scan analyzers against it. I wanted to share a bit about security. I'll just focus on deserialization attacks, because if you're going to run these models, think about the security of that. You know, if we're getting DeepSeek models, there's a lot of people, like, some people say you can't, you know, run models can't include backdoors or like C2, but models are code, but they also are weights. So there's a common framework, Pickle, and it's a way of sharing models as opcode. So if you think about operation code, like it's the lowest level of code. If you've written assembly, that's the English kind of letters for that code. That's what you're getting these models in. So you can see in this, I introduce a malicious class that I then execute. When I load this model, it executes a C2 listener. Models have been found on Hugging Face to have these. It's called deserialization attack. Use safe protocols when possible, safe tensors. If you're going to run models, use safe tensors. I think I'm running out of time, and I want to be respectful of that. So I have a few more slides. I misestimated my content time here, but I'll post all this on a site, and I'm happy to talk to anyone out and later today if you see me around. But yeah, I appreciate everyone's time. Thank you all for coming out, and hope you guys have a great rest of the conference.